Hello students, welcome to BioSmart Academy. In today's lecture, we were going to discuss about a very important topic, that is PI, or you can call it isoelectric point. Okay, so in today's lecture we will going to brief this isoelectric point. Okay, so before I start this lecture, I just want to recommend you that please go through the previous lectures of biochemistry that were already uploaded on this YouTube channel. Please go through all the lectures of amino acid. There are 4 lectures on amino acid. Please go through it. Very important from examination point of view, and also very important from understanding today's lecture. Okay, this is the basics of biochemistry. Clear? So let's start today's lecture, that is isoelectric point. Okay, so before I start this lecture, I just want to mention some point. There will be 3 lectures on isoelectric point. Okay, and out of these 3 lectures, in today's lecture, that is the first lecture of isoelectric point, we will mainly discuss about the basics of isoelectric point. Okay, and in next 2 lectures we will discuss how to calculate isoelectric point, for polar and non-polar amino acid. Clear? So please follow BioSmart Academy. This YouTube channel provides you free online lectures, and all these lectures are very important from examination point of view. Okay, so let's start today's lecture, that is basics of isoelectric point. Okay, now, so first of all we should know that what is actually isoelectric point. Okay, so let's understand with the help of a pH scale. So suppose this is a pH scale. Clear? Now, if we see the pH scale, this is pH 1 to pH 14, this is pH 14. Clear? Now, and this is somewhere, this point is a neutral point. This point is a neutral pH. Okay, we consider pH 7 as neutral pH. Clear? So what is actually isoelectric point? Isoelectric point is basically point along this pH scale, which neither belongs to this pH, that is from pH 1 to pH 6, or neither belongs to this pH. That is, in another word, you can say, which is neither positively charged or neither negatively charged. So isoelectric point is the point which is somewhere near the neutral pH, which is basically in the neutral pH, that is neither contain positively charged and nor contain the negatively charged. So this is isoelectric point. So in case of isoelectric point, the overall charge on the molecule become 0. As it neither positively charged nor negatively charged, so the overall charge becomes 0. Now, if you want to understand with the help of an you can say general amino acid structure, then you can understand with this structure. Okay, so this is the CO minus, this is the NH3 plus, this is a hydrogen, and this is a R. So this is a general structure of amino acid. Okay, so here you can find that positively charged, which is basically present on the carboxyl group, and this is a negatively charged, which is present on the carboxyl group, and this is a positively charged, which is present in the amine group. It means this molecule contain both positive and negative charge, and if we calculate the charge, then what happen? This is -1, this is +1. Clear? This is -1, this is +1. So overall charge become what? +1 minus 1, that is 0. So this is a molecule. Okay, so this is, we can call it isoelectric point. And remember one point, at specific value of pH, at specific value of pH, which is basically we can call isoelectric point, every amino acid exists as dipolar ion. So we can call this structure as Zwitterion, or you can call it as dipolar ion, or you can call it as dipolar ion. Why dipolar ion? Both contain positive as well as negative charges. Okay, so in this point you can say that pH is just equal to pi, Okay, so a Zwitterion, what is Zwitterion? So see the definition. What is Zwitterion? A Zwitterion is a compound with no overall electric charge but contain positively and negatively charged group. Okay, with no overall electric charge. The overall electric charge is 0 but contain positively as well as negatively charged group. So this is Zwitterion. Clear? So this is a basic introduction about the, you can say, isoelectric point. And another form of this point is that Zwitterion. And Zwitterion exits at specific pH of called isoelectric point, where pH is just equals to pi. That is, you can say, intermediate pH. Okay, clear? So this is all about the isoelectric point. Now, so I hope till now you get a clear idea about the isoelectric point. Now look at this structure. See, this is a general structure of the amino acid. Okay, this is a general structure of the amino acid. Okay, clear? This is a structure of Zwitterion. Okay, now if we put this Zwitterion, if we take this general amino acid or Zwitterion and put it in a solution of very low pH, then what happen? If we put the solution of very low pH, let's say pH 1, then what happen? Then this CO minus become COH, and the overall charge of this molecule become 1, just this charge, +1, because it become neutral, COH. So the overall charge on this molecule become 1. Why this become neutral? As at very low pH it contain lots of H plus ion. Because of this it become neutral. So the overall charge on the molecule become 1. Clear? I hope till this much you got a clear idea. Now in another sense, if we put, so this is the Zwitterion. Okay, now if we put this amino acid in very high pH, say pH 11, then what happen? If we put it in a very high pH, then what happen? Then this amino group loses its proton, and it become what? It become NH2. Okay, so this amino group loses its proton because it contains lots of OH minus. So this amino group loses its proton and it become NH2, and that is become uncharged. So in this case the overall charge on the molecule become what? -1. That is negative. This charge only remain. So only -1. So overall charge on this molecule become -1. Clear? And if we see a pH where it become equal to pi, where both the charge exit, that pH is the pi. That is isoelectric point, you can say. Okay, so isoelectric point is that point where the overall charge becomes 0, or you can say that point where both these charge exist, that is minus and plus. So that is pi. Clear? So this is a basic introduction about the isoelectric point. And how to calculate this isoelectric point? Okay, if I just take an example by this general formula. Okay, if this is a general formula of the you can say amino acid. Okay, so if we take just look at the formula. Okay, we apply this formula, or we can see some formulas for polar and non-polar amino acids specifically in our next two lectures. Okay, just for general idea, just for look at this general formula. Okay, so this CO minus, we take this as pKa2. Okay, as an average value. Okay, if you look at the average value of pk1 or pk2, so this general CO minus we can take as pk2. Okay, pk2 as an average value. Okay, while in case of amino, you can take as pk approx 9. So you can take pk1 as approx 2, and this is pk2 approx 9 for amino acid. This is a general formula. Okay, it may be more than 9, that is 9.6, 9.3, 9.6, maximally that is 9, except in case of proline, which is above 10. Okay, and 16 above 10. So that are the special cases. We will look all that things in our next upcoming lectures. Okay, so how can we calculate? So isoelectric point can be calculated easily. pk1 plus pk2 by 2, that is 9 plus that is you can say 2 plus 9, that is 2 plus 9, that is 2, that is 11 by 2, that is 5.5. So this is a general calculation for isoelectric point, that is 5.5. Okay, so this is the basics of isoelectric point, basic idea about the isoelectric point. So what we have learned in this lecture, we learn about the definition of isoelectric point. We learn what happen when we put isoelectric compound or zwitterion compound at very low pH and at very high pH, what will happen. And we also learn a general formula for isoelectric point. Okay, so that's all for today's lecture. Remember students, in our next two lectures of isoelectric point, we will discuss briefly about how to calculate isoelectric point for polar amino acid, for non-polar amino acids, as well as for special cases. For example, how to calculate isoelectric point of cysteine, how to calculate isoelectric point for proline. These are the special cases. Okay, so we will look all these things in details in our next two lectures of isoelectric point, and your all confusion will be cleared. So please be remain with Biosmart Academy. Please subscribe this channel, and if you like this video, please share it. Okay, so we will meet in our next lecture of isoelectric point. Till then, thank you.